And hi everyone, so in this slide, we are going to present about logical connective. First of all, statement and logical connective. So basically, statements are known as proposition is a declarative sentence that either true or false but cannot be both. If you want to know, statement cannot have question mark or exclamation mark. Then, primitive or simple statement is statement that can be represented by a variable like P, Q, and R. The truthfulness or falsity of a statement is called its truth value. Statement can combine biological connectives, and the truth value depends on the types of connectives that we use. This is a table that contains compound statements formed by the connectives, logical connective, and the symbol. N is logical connectives for conjunction, R is logical connectives for disjunction, not is logical connective for negation, if then is logical connective for conditional, if and only if is logical connective for biconditional. The symbol as you guys can see in the table.
Hi, I'm Hanani and I will explain a true value and true table. A true value is a true or falsity of the statement of the proposition. A truth table displays the relationship of the truth value of the statement. If a compound statement has two variables, let's say P and Q, then the truth table must be constructed with 4 rows. On the other hand, if a compound statement has 3 variables like P, Q, and R, then the truth table have 8 rows. This thing can be simplified to a formula 2 powered by n, where n is a number of the variable. Q represented by digit 1 and 0, where 1 is true, 0 is false. Next, negation. The negation of statement P has a opposite true value from it. The negation denies the original statement. The negation of statement P denoted by not P and read as a not P. If P is true, then not P is false. If P is false, then not P is true. For example, the statement P, proving method is easy, not P, proving method is hard. It means the true value of the negation is always the opposite to the true value of the original. After that, I will explain conjunction. Conjunction is used to combine two primary statements by using the word and to combine to form a compound statement. The conjunction of two statements P and Q is denoted by P and Q. The true value of conjunction is determined by if P is true and Q is true, then P and Q is true. Otherwise, I will explain disjunction. Disjunction also used to combine any two primary statements by using the word or to combine a compound statement. Disjunction of statement P and Q is denoted by P or Q. The true value of disjunction is determined by if P is true or Q is true, or both Q and P is true, then P or Q is true. Otherwise, P or Q are false. Here are the example of truth table. As you can see on the left side, the truth table of negation. As you can see, if P is true, then not P is false. If Q is true, then not Q is false. On the middle part, you can see truth table of conjunction. as you can see on the bottom part of table, if P and Q are both false, then P and Q are false. Otherwise, it's true. Lastly, as you can see in the truth table of disjunction on the top, that if P and Q are both true, then P or Q are true. Otherwise, it's false.
For conditional statements, the term conditional statement refers to compound statement with the form if P then Q, where P is the antecedent, which is hypothesis, and Q is the consequent, which is conclusion, written symbolically as P implies Q. The truth value for P implies Q satisfies the following property. If P is true and Q is false, then the conditional P implies Q is false. Otherwise, P implies Q is true. Next, we will talk about negations of conditional statements. Negation of P implies Q is written, not P implies Q. We have proved that P implies Q is equal not P or Q. Therefore, not P implies Q is equal not P or Q. The truth table below is proof that the negation of P implies Q is P and not Q.
Now, I would like to present about biconditional statement. We now discuss what it means for two statements to be equivalent. The symbol we use for this is this. And P biconditional Q is often read P if only if Q. Logically, this statement is equivalent to P implies Q and Q implies P, and means that the two statements have the same truth values or truth tables. The truth value for biconditional P biconditional Q satisfies for the following property. If P and Q have the same truth value, then P biconditional Q is true. But if P and Q have opposite truth value, then P biconditional Q is false. So, the table below shows how the truth table of biconditional will look. Now, let's discuss about tautology, contradiction, and contingency. Firstly, tautology. Tautology is a statement that is always true regardless of the circumstance in mathematics. Let us look at the following statement. My favorite food is chicken, whether it is fried or not. In symbolic, the above statement is written as P or not P, where P is my favorite food is fried chicken. So, the truth table below shows clearly that any statement of the form P or not P is a tautology. Secondly, contradiction. Contradiction is assertion of a statement and it is negation. It is a statement that can never be true. A contradiction is equivalent to the negation of a tautology. Table below show that the P and not P is contradiction. And then we can also show the statement P and not P or Q is contradiction by using truth table. In this table, it shows all values is 0, which is false. Then that is how contradiction happens. Lastly, contingency. Contingency will happen when the truth values contain both true and false. The following example shows an example of contingency. What you can see, the truth values have both true and false. So it clearly shows that it is contingency. This is example 1. The question is write down using the proposition symbol to represent each of the following primary statement. In this question, it gives that P, Anna goes to school today, Q, Anna is sick, and the last one is R, Anna goes to see the doctor. In this table, the statement is Anna does not go to school today and she goes to see the doctor. This statement is conditional because it has an in the middle. So the symbol for this statement is not P and R. For the second statement, if Anna goes to see the doctor, then she is sick. In this statement, it has if-then. So the compound statement is conditional, where Anna goes to see the doctor is hypothesis and she is sick is conclusion. It can be written as R implies Q. Third, Anna does not go to school if and only if she is sick. This is a biconditional statement since it has if and only if. So the symbol that we use is not P if and only if Q. And the last statement, Anna is not sick and she not goes to see the doctor. In this statement, it has negation and conjunction statements. So the symbol is not Q and not R. And that's it.
Example question 2. Construct the truth table for the following compound statement. The compound statement that we have here, P and Q or R. First is list down all the possible true value for variable P, Q and R. As I said earlier, if a compound statement have 3 variables, the truth table will have 8 rows by following the formula 2 power by n, where n is a number of variables. After we list down all the possible true value for the 3 variables, we will construct the statement Q or R first and list down all the possible true value for or if a true value both are true, then P or R is true, otherwise it false. After that, we construct this compound statement P and Q or R. For n, if a true value are both false, then the true value for P and Q or R is false, otherwise it's true. Now, let's move on to example question 3. The question is, by using truth table, determine whether P and not Q or P implies not Q is tautology, contradiction of contingency. So, the truth values of this statement is 1, 1, 1, 0. Since the truth values contain both true and false, therefore the statement is contingency. And this is how we find the answer.
Conclusion is, symbols are used in propositional logic to identify the relationships between statements. Logical connectives such as conjunction, which is and, disjunction, which is or, negation, which is not, conditional, which is if, and biconditional, make these relationships possible. Other than that, compound statements, which are made up of at least 2 simple statements, is combined by using connectives. A statement is a piece of information that can be true or false. Last but not least, truth tables, a graphic way of showing all the truth value possible outcomes and can be used to illustrate the possible truth values of statements and arguments.